Hello, class, and welcome to Chapter 6, Section 2, where we will talk about how we classify the elements of the periodic table. And this Chapter 6 really goes into detail, of how we use and understand the periodic table, and we're taking just kind of portions of it at a time. So in this section, let's first look at reading the periodic table. The periodic table usually displays the symbols and names of the elements along with information about the structure of their atoms. This figure will show one square from a detailed periodic table of the elements. As you can see here, we see the atomic number, which is the number of protons. It shows the aluminum, and then the atomic mass, which is the number of protons and the number of neutrons, because the number of electrons is so minimal. So in the center is the symbol for aluminum, Al. The atomic number for aluminum 13 is above the symbol. The element name and atomic mass are below the symbol. This figure shows one square. Again, there's also a vertical column with the numbers 2, 8, and 3, which will indicate the number of electrons in each occupied energy level of an aluminum atom. The symbol for aluminum is printed in black because aluminum is solid at room temperature. The symbols for gases are in red, and the symbols for the two elements that are liquid at room temperature, mercury and bromine, that's Hg and Br, will be blue because they're liquids at room temperature. And then the symbols for some elements are in gray, and these elements are not found in nature, but they were synthesized in a lab. So you can see a couple of the one. So remember, periods are rows and groups are columns. So group 1 are the alkyl metals. Group 2 are the alkaline earth metals. Groups 3 to 12 are transition metals. Group 17 are the halogens. Group 18 are the noble gases. And then we have the individual hydrogen group. So again, we have groups as these columns. We can see, and the periods are the rows. Group 1, the alkaline metals are shown here. So that would be here, these elements under hydrogen. They have one valence electron, and they lose one electron to form positive ions. They're extremely reactive with water, and the most reactive metal is francium, Fr. Group 2 are the alkaline earth metals. They have two valence electrons, again, showing this group starting with beryllium down to radium. They can lose 2 electrons to form a positive 2 ion charge. 12 are the transition metals. They're the least reactive metals, and they form colored ions in solution. So when we combine them with some sort of solution, these elements will form a colored ion. Group 17 are the halogens. They have 7 valence electrons. They will gain an electron to form a negatively charged ion, and the most reactive nonmetal is fluorine, letter F. Group 18 are the noble gases. They're unreactive inert because they have a stable octet. They have 8 valence electrons, which can fill up all of those electron energy levels. So we call them chemically stable. They're unreactive, they're inert because these are stable elements that don't need to gain or lose an electron. The exception is helium, which has 2 valence electrons, and they're all monatomic, meaning there's just one atom per each. Hydrogen is not officially part of a group, so we call it just the hydrogen group. It's a nonmetal, and it's a gas at standard temperature. Electrons play a key role in determining the properties of elements, so there should be a connection between an element's electron configuration and its location in the periodic table. Elements can be sorted into noble gases, representative elements, transition metals, or inner transition metals based on their electron configurations. The noble gases are shown here, and their electron configurations for the first 4 noble gases are listed below: helium, neon, argon, and krypton. And you can see those electron configurations that we practiced a lot doing in previous sections. Look at the last part of the electron configuration for all of the noble gases listed. It's highlighted in yellow. You can see that their S and P sublevels are completely full, and this allows for the noble gases to be non-reactive. So that's what makes them fairly stable and non-reactive. The representative elements, so this figure shows a portion of the periodic table containing groups 1A through 7A. And elements in groups 1A through 7A are often referred to as representative elements because they display a very wide range of physical and chemical properties. Some elements in these groups are metals, some are nonmetals, and some are metalloids. Most of them are you can see that's listed in blue. In atoms of the representative elements, the S and P sublevels of the highest occupied energy level are not filled. And in atoms of these group 1A elements, there's only one electron in the highest occupied energy level. So you can see how the electron configuration really determines where we are placing these elements in the periodic table. In atoms of the group 4A elements, carbon, silicon, germanium, there are 4 electrons in the highest occupied energy level. And for any representative element, its group number will equal the number of electrons in the highest occupied energy level. So in group 4A, there are 4 electrons in the highest occupied energy level. In the periodic table, the B group elements separate the A groups on the left side of the table from the A groups on the right side, and elements in the B groups are referred to as the transition elements. There are 2 types of transition elements, metals and inner transition metals, and they're classified based on their electron configuration, like everything else. The transition metals are the group B elements that are usually displayed in the main body. The highest occupied S sublevel and a nearby D sublevel will contain electrons, and these elements are characterized by the presence of electrons in their D orbitals. The inner transition metals are the elements that appear below the main body of the periodic table, and in atoms of these elements, their highest occupied S sublevel and a nearby F sublevel generally contain electrons, and these inner transition metals are characterized by the presence of electrons in the F orbitals. Before scientists knew much about these inner transition metals, people referred to them as the rare earth metals. And this name is misleading because some inner transition metals are actually more abundant than other elements. And notice that some of the inner transition metals are not found in nature. These elements were prepared in laboratories using methods that we will talk about in chapter 25. That's the end of this section. Again, we're kind of just taking our way through learning about the periodic table, and we'll have the same next week. Thanks for listening.